Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
Welcome to question 6 of the CSET Math June 2012 video solution. And this question tells us of an enlargement transformation where triangle LMN is mapped onto triangle PQR, and we can see that in the diagram here. Now, enlargement is the transformation that deals with a scale factor where there's a change in size from object to image, and there's also a center of enlargement. Let's talk about the center of this enlargement. Now, because the image and the object are pointing in the same direction, that is telling me that the object and the image are on the same side of the center. And since the enlargement is from this triangle to this triangle that's in this direction, that means that the center of the enlargement is somewhere on this side. If we now consider the scale factor, all we need to do is compare the distances on the image with the distances on the object. And if we compare these two sides, which are corresponding sides, this image distance or this image length is 6 units, while this corresponding object length is 3 units. So there's an increase of 2 times, and hence the scale factor is 2. Also, if you compare this length on the object with this length on the image, we see that QR is 4 units while MN is 2 units, and so the scale factor is 2. The scale factor is also a positive 2 because the image and the object are pointing in the same direction and they are located on the same side of the center, because as we said, the center of the enlargement would be somewhere here. But let's go ahead now and answer the questions. Now, the first question is asking us to locate the center of the enlargement. And to locate the center of the enlargement, all we need to do is join the corresponding points and extend those lines to meet. Where those lines joining corresponding points meet is the location of the center of the enlargement. Let's show that construction. And this is the first one. L and P are corresponding points, so this is a line joining those corresponding points, and we extend this line this way because we know the center is somewhere here, and then we can join R to N. N and R are corresponding points, so let's join those 2 points and extend that line backwards. And so where these 2 lines joining the corresponding points meet, that's the location of the center of the enlargement. So we can go ahead and put that point in, and the coordinates of that point would be 1, 5. So we can write that here. The center of the enlargement is at the point 1, 5. Now I want to make a point of the scale factor again. Now if you notice this image point P from the center of the enlargement, it is twice the distance as the distance of L from the center of the enlargement. The distance from the center to P is twice the distance from the center to L, and also the distance from the center to R is twice the distance from the center to N, and so that also is indicating that the scale factor is 2. So the scale factor is 2 for 2 reasons: because the sides of the image are twice as long as the corresponding sides on the object, and also the distance of the image from the center is twice the distance of the object from the center. And because the center is on the same side of the image and the object, it means that the scale factor is positive. But let's go and show how the scale factor can be calculated. And this is it. Part B is asking us for the scale factor. Now the scale factor is given by an image length divided by a corresponding object length. Right? And so, as I said, we could use the distance of a point from the center, and this would be an image distance from the center to P, and this would be the corresponding object distance from the center to L. Or we can use a side on the image, which for example is PQ, and divide that by LM, and we can actually use that as our example. So the scale factor is the length of PQ divided by the length of ML, and that would be 6 units divided by 3 units, and so the scale factor is 2. But we could also observe that the scale factor is 2 because the image distances are twice the object distances, and so the scale factor is 2. Now part 3 is asking us for the area of triangle PQR divided by the area of triangle LMN, right? So that is actually the area of the image divided by the area of the object. Now there's a general relationship between the area of an image and the area of an object after an enlargement, and this is it. The area of the image is k squared multiplied by the area of the object, and this is because area is obtained from the product of two dimensions, right? And since the scale factor is k and you have to multiply two lengths to derive an area, it means that you will be multiplying the scale factor k twice, hence the k squared. But generally speaking, the area of an image is k squared times the area of an object, where k is the scale factor. And so if we transpose this general equation, then we see that the area of the image divided by the area of the object would be equal to k squared. And we can show that here, the area of the image divided by the area of the object will be equal to k squared. And since k is 2, it means that k squared is equal to 4. And that's the answer for part C. Let's move down now to part D. Now part D is telling us to draw a triangle ABC such that coordinate of A is negative 4, 4, coordinate of B is negative 1, 4, and coordinate of C is negative 1, 2. So let's show those coordinates on the diagram here. So that's it. A is the point negative 4, 4, B is the point negative 1, 4, and C is the point negative 1, 2. So these are the coordinates for the triangle ABC, and you can go ahead and put in the lines, and hence that is triangle ABC. And then part E is asking us to describe fully the single transformation which maps triangle LMN, that's this one, onto triangle ABC, that's this triangle, onto this triangle. Now we can actually observe that transformation. Firstly, there is some turning, and there's a 90-degree turning, because this vertical line on the object LM became horizontal AB after the transformation, and this horizontal line MN on the object became a vertical line BC on the image, and so we know it's a rotation. But the question is, where is the center of that rotation? And the center of a rotation is positioned in such a way that the distance of an image from the center is equal to the distance of the object from the center. So I am observing that the origin here is the center of this rotation, because if we compare the points, for example, the origin to N, it is 2, 1, and the origin to the corresponding point C is 1, 2. So it is 1, 2, and 2, 1, and hence the distance from O to N would be the same as the distance from O to C. And then if we compare O to M, that's 4, 1, and O to B, that's 1, 4 here. And so the distance O to B would be the same as the distance from O to M. And if we compare OL, it would be 4 and 4. And if we compare OA, it would also be 4 and 4. And therefore the distance from O to A here would be the distance from O to L here. So that is telling me that the center is the origin here. And then to get the angle of the rotation, we would have to construct those rotation lines, object to center to image. So let's go ahead and show those lines. That's object to center to image. This is the rotation line from the origin here, and clearly this angle is 90 degrees and the direction is anti-clockwise. And if we observe another point, M to center to B, again that's a 90 degree, that's the rotation. This line is rotated about the origin here, and the angle of rotation is 90 degrees, and that's it. And so this rotation is an anti-clockwise 90 degree rotation about the origin, and that was all by observation. But let's say we could not observe that rotation and we wanted to use a theoretical approach. What we would do is look at the 4 possible transformations that could maybe transform triangle LMN onto triangle ABC. And the 4 possible transformations are translation, reflection, enlargement, and rotation. And what we could do is eliminate the ones that we are certain that the transformation is not. Now, it is not a translation because there is some turning. Translation is the transformation that moves an object from one location to another location without turning, and so we can cross out translation. It is not a translation. And then we can investigate the possibility of the transformation being a reflection. A reflection is a transformation that reverses orientation. And if we look at the orientation on the object, LMN is clockwise, and on the image, ABC is also clockwise. So the orientation on the object is the same as the orientation on the image. Both are clockwise, and so the orientation was not reversed, and hence the transformation is not a reflection because reflection reverses orientation. Now we want to investigate if it's an enlargement. Now enlargement is a transformation that changes the size of an object, and in this case we see that the image and the object are of the same size because LM is 3 units, AB is also 3 units, MN is 2 units, and BC is also 2 units. So there's no change in size, and hence the transformation is not an enlargement. So the only transformation we have left is a rotation, and we can confirm that it's a rotation because there was some turning. But all we need to do is find the components of that rotation, and the components of a rotation are the center, the angle, and the direction. So let's go now and see how we can find the components of the rotation so we can give a full description of the rotation that maps triangle LMN onto triangle ABC. Now to describe the rotation, we first have to find the center of the rotation, and the center of the rotation is located on the perpendicular bisector of the lines joining corresponding object and image points. So let me show that construction. This line LA is the line joining corresponding object and image points, right? That is point L corresponds to point A, and so this is a line joining corresponding object and image points, and the perpendicular bisector of this line will pass through the center of the rotation, and clearly the perpendicular bisector of this line AL would be the y-axis. So we can go ahead and show that perpendicular bisector, and this is it. So the perpendicular bisector of the line AL is this line. We need one more perpendicular bisector, and so we can join the points M to B because M corresponds to B. So this is the line joining corresponding points between the object and the image, right? So BM is the line joining corresponding points, and now the perpendicular bisector of this line will also pass through the center of the rotation. So if we construct now the perpendicular bisector of that line, we see that it intersects this first perpendicular bisector here at the origin, and so this point is the center of the rotation, right? And we can go ahead and mark that point. So that is the center of the rotation, and we have done it by construction. Two perpendicular bisectors of lines joining corresponding object and image points. That's how we construct to find the center of a rotation. After we have constructed to find the center of a rotation, we need now to construct to find the angle of the rotation. And that construction is done by joining an object point to the center to an image point. And we can show that construction. That's object to center to image. And the angle formed here is the angle of the rotation. And clearly that's a 90-degree angle, and the direction is anti-clockwise. And so we have all information we need now to give a full description of the transformation that maps triangle LMN onto triangle ABC, and that is an anti-clockwise 90-degree rotation about the origin. Alright, and we can go ahead and write that statement. The transformation is an anti-clockwise 90-degree rotation about the origin. The three components of rotation must be stated in the description, and the components are the direction, which in this case is anti-clockwise, the size of the rotation, the size of the angle of the rotation, that's 90 degrees, and the center of the rotation is the origin in this case. So that's it. The transformation is an anti-clockwise 90-degree rotation about the origin. That's the transformation that maps triangle LMN onto triangle ABC. So that's the answer for this question 6, and we'll do question 7 in our next video. Okay, see you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.